Hello everyone. Today we bring to you the citric acid cycle or the tricarboxylic acid cycle, and we bring a simplified version of this. This is a topic from biochemistry and this is brought to you by VrikshOnline.in. Before I begin, I would like to request you to like and share our video and do not forget to subscribe our channel VrikshOnline.in on YouTube. Today we would discuss importance of TCA cycle in metabolism, overview of the cycle, an interesting poem to remember the cycle, stepwise breakdown of the reactions. This is what we are going to see today. Now let us understand what is TCA cycle. What is its importance in the metabolism? Animals consume macronutrients in the form of carbohydrates, lipids or fats, and proteins. Many people eat sugar, starch, wheat, etc., which are carbohydrates. These carbohydrates break down into glucose. The examples of lipids or fats that we consume are cheese, oil, ghee, butter, etc. And these are also important sources of energy, which finally in the body break down into fatty acids plus glycerol. We eat a lot of proteinaceous diets, for example, egg, meat, beans, etc. And these break down into amino acids. But hey, what happens to these monomers after they break down? They finally undergo metabolism. Glucose undergoes glycolysis. Fatty acids and glycerol undergo fatty acid metabolism. And amino acids undergo amino acid metabolism. Finally, they all form acetyl coenzyme A. Why acetyl coenzyme A? If you ask a simple question, why do we eat food? We eat food to get energy. Where does that energy come from? That energy comes from entry of acetyl coenzyme A into the TCA cycle. And the TCA cycle gives energy. So acetyl coenzyme A enters the TCA cycle. The first reaction in the TCA cycle is the reaction of acetyl coenzyme A and oxaloacetate in the presence of citrate synthase to give citrate. Why the name TCA? This is because citrate has 3 carboxylic acids, hence the cycle is called citric acid cycle or the tricarboxylic acid cycle. Let us now look a little bit into more details as to what is the cycle about. So this is the TCA cycle. Wow, I don't think I can ever remember this if I am given in this form. So let's see an interesting poem by which we can remember the cycle. I have made this. I hope you find it interesting too. The title of this poem is Ox on Diet. So the poem goes like this. Ox ate citrate. Citrate became isocitrate. Ox went on a keto diet. It succeeded with its co-workers. It succeeded itself. All were fuming with hunger. Ox ate mallet, drank water. Ox survived and the cycle continues. But what it has to do with the citric acid cycle? Let us have another look and see. Ox ate citrate. The first metabolite in the TCA cycle is oxaloacetate. Citrate is the second metabolite that we come across in the TCA cycle. Citrate became isocitrate, that is our third metabolite. Ox went on a keto diet. The fourth metabolite is alpha-ketoglutarate. It succeeded with its co-workers. Now the fifth metabolite that we come across is succinyl coenzyme A. It succeeded itself. The sixth metabolite is succinate. All were fuming with hunger. The seventh one is fumarate. Ox ate mallet, drank water. So the eighth one and the last metabolite in the TCA cycle is malate. Drank water is because this reaction happens in the presence of water. Ox survived and the cycle continues. That means oxaloacetate formed again and the cycle continues. So this is the significance of the poem, and wow, this is so easy to remember now. Let's repeat it once again. Ox ate citrate, citrate became isocitrate. Ox went on a keto diet. It succeeded with its co-workers. It succeeded itself. All were fuming with hunger. Ox ate mallet, drank water, ox survived, and the cycle continues. So if we look at the TCA cycle now, well, that looks pretty easy now. We have oxaloacetate. So ox ate citrate. Citrate became isocitrate. Ox went on a keto diet. It succeeded with itself. All were fuming with hunger. Ox ate malate, drank water, and the cycle continues as the ox survived. So we have oxaloacetate, citrate, isocitrate, alpha-ketoglutarate, succinyl coenzyme A, succinate, fumarate, malate, and goes back to oxaloacetate. Wow, that's pretty easy now. Let us now look at little more details. We will look at the reactions of the TCA cycle. Let us now have a look at the reactions of the citric acid cycle. As we said, it begins with the condensation of acetyl coenzyme A with oxaloacetate. Citrate is formed and that gives the cycle its name, Tricarboxylic Acid Cycle. So let us have a look at how citric acetyl coenzyme A condenses with oxaloacetate. So this is the structure of acetyl coenzyme A, and oxaloacetate is a C4 compound. You can see that there are 4 carbons in this, and these condense in aldol condensation reaction, and via aldol condensation reaction it forms an aldol which is citryl coenzyme A. Citryl coenzyme A then undergoes hydrolysis, and after this it forms citrate. This citrate, as you can see, there are 3 carboxylic acids in its structure, and therefore this cycle gets the name tricarboxylic acid cycle, that is TCA cycle. So acetyl coenzyme A to citrate is the first reaction. Let's move on to the next reaction, which is isomerization of citrate into isocitrate. In this reaction, first of all, you might think, why does citrate need to isomerize into isocitrate? If we look closely at the structure, citrate is a tertiary alcohol. You can see that this carbon is a tertiary carbon and this is a tertiary alcohol. In the next step, this tertiary alcohol needs to react. And it is not possible for a tertiary alcohol to react as good as a secondary alcohol. So in this step, what happens is a tertiary alcohol converts into a secondary alcohol through a mechanism. In the presence of aconitase, an addition of water occurs and this citrate forms cis-aconitate. Again, a reversible reaction occurs and then this alcohol moiety is transferred from a tertiary carbon to a secondary carbon. Now this secondary alcohol is highly reactive and it can undergo further reactions. This is why citrate converts to isocitrate. So this is the second step of the TCA cycle. So now let us look at the third step, which is oxidative decarboxylation of isocitrate. What happens in this step? Now this step has 2 substeps. One is the conversion of isocitrate to oxalosuccinate and then oxalosuccinate to alpha-ketoglutarate. Now in both of these steps, the enzyme is the same, that is isocitrate dehydrogenase. So in the first step, what happens is isocitrate leaves out a hydrogen molecule, NAD plus comes and picks it up. And NAD plus then converts into NADH plus H plus. This isocitrate then forms oxalosuccinate. If you observe oxalosuccinate carefully, with respect to this carboxylate group, it is a beta keto acid. So in the beta position, there is a ketone group. So it's called a beta keto acid. As we know from our knowledge of organic chemistry that beta keto acids are very unstable and easily lose this carboxyl group. So you can see that in the next step, this carboxyl group is lost as carbon dioxide and therefore we get alpha ketoglutarate. So alpha ketoglutarate 1, 2, 3, 4, 5 is a 5 carbon compound. So it's 5C compound Oxaloacetate was a 4-carbon compound, and from there we have come to a 5-carbon compound. Let's look at the next step. The next step is oxidative decarboxylation of alpha-ketoglutarate. It is another decarboxylation step in sequence with the previous decarboxylation step. How does this happen? So alpha-ketoglutarate is a C5 molecule, that is, it contains 5 carbons. Now what happens in this step is in the presence of coenzyme ASH and NAD+, and inside this alpha ketoglutarate dehydrogenase complex in the presence of magnesium, this carboxyl group is substituted by coenzyme ASH. So a sulfide bond happens and sulfur comes in this place and you get succinyl coenzyme A. NADH is released in this process, so a conversion of NAD+ to NADH happens. Let us go to the 5th step. Wow, we have now covered 4 steps of the cycle, and that was super easy, I believe. So we go to step 5 and see what happens next. The next step, as the poem goes, the ox succeeded with its co-workers and then the ox succeeded itself. So now it is succinyl coenzyme A and then it is succinate. So this is the 5th step, which is the conversion of succinyl coenzyme A into succinate. How does this happen? This involves a few kinds of molecules, but don't bother too much. Just see the succinyl coenzyme A structure. As we can see, this is a 1, 2, 3, 4. It is a C4 molecule. There are 4 carbons, and succinate also is a C4 molecule. The difference between succinyl coenzyme A and succinate is basically in this carbon, in the last one, that is S coenzyme A leaves and C double bond O becomes C double bond O minus. How does this happen? So first a phosphate molecule comes and adds on to the C double bond O there, and S coenzyme A being labile, it breaks up. It breaks down and then a phosphate molecule adds on there, and in the presence of GDP, a magnesium molecule is also present there, and then this succinyl phosphate then converts to succinate. Once this happens, a molecule of GDP is also converted to GTP. That's called a substrate level phosphorylation, and there is some amount of energy even released in this. Let us now go to the next step, which is dehydrogenation of succinate to fumarate. So as the poem goes, all were fuming with hunger. So we come to the fumarate step. Succinate is a 4-carbon compound, as we saw, C4. Fumarate is also a 4-carbon compound. There is no increase in the number of carbons in this step. Instead, what happens is, in the presence of succinate dehydrogenase, as the name suggests, it picks up a hydrogen molecule from succinate and it picks up these methylene protons. From these methylene carbons, it picks up the molecules of hydrogen and then leaves a double bond. So you can see that there in succinate, this was C single bond C, whereas in fumarate, it is C double bond C. So the molecule has become unsaturated and it has got dehydrogenated. In turn, what happens is there should be an electron, there should be a hydrogen carrier as well when such reactions happens. So FAD is the electron carrier and it in turn converts to enzyme FADH2 complex. Let's go to the penultimate reaction of the cycle, which is hydration of fumarate to malate. Interestingly, fumarate then converts to malate and by adding on a water molecule. So as the poem goes, ox ate malate, drank water. Ox survives and the cycle continues. So hydration of fumarate to malate is accompanied by an addition of water molecule. So ox has to eat malate and has to drink water. So the fumarate molecule adds on a molecule of water in the presence of fumarate hydratase enzyme. This is the enzyme, and what happens in turn is you get this L-malate where you have water molecule added across the C double bond C. So this is the moiety where water molecule adds. You can see a significant difference in the this moiety, which I have highlighted. The last step in the reaction is dehydrogenation of malate to oxaloacetate. How does this happen? So L-malate is again a C4 compound and oxaloacetate is also C4 compound. So in the reaction, no change in the number of carbon occurs, but in the presence of L-malate dehydrogenase, This L-malate gives a molecule of hydrogen to NAD+, which converts to NADH plus H+, and in turn, what happens is this particular carbon, the second carbon, becomes from alcohol, it oxidizes to a ketone. So basically, it's an oxidation reaction. And so we get back oxaloacetate. So ox-8 malate, ox survives, and oxaloacetate is formed back, and the cycle continues. With these reactions, the TCA cycle is really easy for you. Guys, do share the poem with your friends. Do like and share these things. And I hope now you could understand the TCA cycle easily. We have looked at the reactions of TCA cycle. Practice them on your notebook and get them all across. And I have a very exciting news for you. CSIR UGC NET classes for 2022 have begun from VrikshOnline.in. Do visit our website VrikshOnline.in and contact us at VrikshOnline@gmail.com for more information. We are giving you very good online classes at this. So please do like and share our video and do subscribe our channel on YouTube. We are also there in Instagram now, so please support us. Thank you.